Hi guys, welcome to our third video in chapter 20. This video is going to cover section 20.3 and is all about half reactions. So our objectives for this video are pretty straightforward, right? Recognize the interdependence of oxidation reduction processes. We need one for the other one to happen, right? We want to derive oxidation reduction half reactions from a redox equation, and then we want to be able to balance those half reactions, right? A couple of new vocab words, species and half reaction. So to get right into it, a species in chemistry, it's any kind of chemical unit involved in a process. So I've used it before, you've heard it before, but it's time we formally defined it. It is simply anything doing a chemical process. More importantly, a half reaction is one of the two parts of a redox reaction, either the reduction side or the oxidation side, all by itself. This is extremely useful for us determining how many electrons are transferred. And I have a table here that shows us the complete unbalanced reaction, and then it shows us our oxidation and reduction half reactions. So you can see for the formation of iron 2 oxide, we take iron combined with oxygen and we form iron 2 oxide, or sorry, iron 3 oxide. Nice, easy stuff, straightforward things. Now, if we want to get more specific, what we can do is take our iron and say this iron, which initially would have had an oxidation state of 0, is going to end with an oxidation state of +3. So that must mean that it gave up 3 electrons. And so we say that iron goes to the ion of iron 3 plus its 3 electrons that it gave up, right? It separated them. So now we say them separately. Likewise, my oxygen started at 0, right? Neutral oxygen with bonded to itself. And then it ends at a -2 charge. And I have 2 oxygens, right? Because it's O2. And so for my equation, what I can write is that I take my O2 plus 4 electrons, and I'm going to form 2 oxide ions, right? Where I have 2 -2 charged oxygens. And I encourage you to go through this table and just see if you can identify what the half reactions are as listed. Pretty clearly, you can identify right off the bat that our iron going from neutral iron to iron 3, that's all going to look the same, no matter what process is happening here. So you can see that this actually helps us simplify a little bit of our redox processes because I have just my oxidation, just the side that is giving up electrons. So again, my oxidation, this is the side that's giving electrons. Maybe I can make a note of that. Oxidation, say this gives electrons, we'll say E minus, right? Gives the electrons. And then if we are talking about our reduction half reaction, this is going to take electrons. It's going to absorb those electrons. And because we've normalized this table by the oxidation half reaction, the reduction half reactions are all changed, but you can see it's the same process. For the reduction half reaction, you take your species, you add electrons, you get a negative charge. You take your positive species, you add electrons, you get a neutral charge, right? Or you take a positive species, you add some electrons, you have a less negative charge in general, right? So in any case, we're going to, or a more negative charge. In any case, we are going to be reducing our charge by adding electrons for reduction or increasing our charge by giving away electrons in oxidation. So that is the useful process of separating these two processes into separate half reactions, the oxidation half and the reduction half. Now, I would like to talk about, first, I want to show you guys a very common redox process. You can see our respiration. This is our cell respiration. And there is an oxidation process where glucose is oxidized, loses electrons, and forms our carbon dioxide molecules. So that's reduction. At the same time, our oxygen molecules, they are gaining electrons, and so they are reduced and form water, right? And the hydrogen ion is also transferred around here. So that is an example of the reduction half in red and the oxidation half in blue of a single process. So let's look at the steps for how we might balance a chemical equation. Like, for example, we can balance by half reactions this somewhat complicated reaction where we take iron, add copper sulfate, we form solid copper, and an iron 2 sulfate. Okay, not crazy. You could probably do this by counting atoms and ions, but let's see what the half reactions method has. Step 1 of this process, as you write the net ionic equations for the oxidation and reduction while omitting spectator ions. So that means that you just don't write down the things that don't do anything. So if we have sulfur, we have our SO4, that is going to be omitted because it is not actually changing. It goes from SO4 to SO4. So we say that has not changed. So we take it out to make our lives a little bit simpler, right? And we're going to go through and we're going to write out our Fe plus Cu2 plus, right? We got rid of the sulfate, so now it's just copper 2 goes to solid copper plus our iron 3, so Fe3 plus. Now, moving on, we want to write these out, separate these into two separate half reactions. Iron goes from neutral iron to iron plus 3, okay? So that means that I take my iron and I must be forming two Fe3 plus ions, and I'm releasing 6 electrons. That means that I'm giving up 3 electrons from each iron atom. The copper side starts at +2 and it's going to end at 0, which must mean that my copper ion is going to be absorbing 2 electrons. It's going to be absorbing 2 of these electrons. All right, and so that's where my my half reaction comes from. Absorbs 2 electrons to form neutral copper. Okay, so now you can see that I have released 6 electrons from my oxidation half where my charge is going up, and I have absorbed 2 electrons from my reduction half where my charge is going down. Well, I've got to go in and I've got to make sure that these balance. So what I can do is add a 3 in front of my reduction reaction, and that's going to see I have 3 copper ions, each accepting 2 electrons for a total of 6 electrons to form 3 coppers. And then that, of course, that means that we will have released 6 electrons here. We will have absorbed 6 electrons here. They cancel out. So we're left with 2 Fe's combining with 3 copper 2s to form 3 coppers and 2 iron 3s. All right, so that's my net equation here. And then I can throw the spectator ions back on. So the copper 2 plus becomes copper sulfate, and the Fe3 plus becomes iron sulfate. And then I've balanced my equation. And this would be my balanced equation at the end here. Okay. All right, guys. That's all I have for this video. Thank you guys for listening. I'll see you in the next one.